I want to believe you can see the screen as clear as possible. And the screen is divided into two. We have on one part the tutorial questions, and on the other part you have the notes where to write. And what I'm writing to as well is clear. So today's date being the 29, let me put the date, 29/11/2024. All right. So once again, you are welcome to the first tutorial session for this particular course, Educ 802, the second semester. We thank God we are here after the break. So welcome back. On the tutorial questions, you have 50 questions, right? If I'm not mistaken. Whoa. Okay. Okay, it's not fully loaded. All right. So we have 50 questions. So let's go over it. One thing I want to call your attention is that this particular tutorial questions, we have the first 20 items to be on conceptual problems, no calculation at all. While the last 30, you have calculations. So my suggestion is for these first 20, which are all conceptual problems, perhaps we should just take maybe 4 out of 20. Then we can have some time on the computational problems. So if that is okay, that means we'll be taking multiples of 5. All right. So I'm starting with question number 5, so to say. So question 5 says, which type of distribution represents equal probabilities for all outcomes? It's a very simple question. Which type of distribution represents equal probabilities for all outcomes? So you have the normal distribution, binomial distribution, rectangular distribution, and exponential distribution. What is the answer to this? You can just unmute yourself and speak, or you type your answer in the chat. Question 5, what is the answer? Yes?
Rectangular.
What is the answer
Yes, rectangular, sir.
to question 5? Rectangular. The answer is C. And that is correct. Remember when we talk about distributions, we started with the rectangular distribution where you have equal probabilities for each of the events. All right.
Yes.
So the type of distribution that represents equal probabilities for all outcomes is what we call the rectangular distribution. Okay. So we can go to question 10. Question 10 says, why is the normal distribution often used in educational research? There's a question of why. A, it perfectly models small sample sizes. B, it assumes all outcomes are equally likely. C, it approximates Again, it seems the answer here is many natural occurring phenomena. All right. Question 15, it says, without replacement of drawing 2 specific cards in succession without replacement. A, independent probability.
Conditional probability.
Perceived probability. What is the answer to this? Yeah. Unmute yourself and speak, or you put your comment in the chat. Yeah. Is the question difficult or people are afraid to talk?
Conditional.
Conditional probability, sir.
Wow, excellent. The answer is conditional probability, because the probability of drawing the second card is dependent on that of the first one. So it is conditional probability, in which the answer there is what? Is B. Question 20, the last question on the conceptual problem. How are probabilities determined in a rectangular distribution? How are probabilities determined in a rectangular distribution? A, based on observed frequencies. B, proportional to the number of events in the sample space. C, unequal and dependent on each other. D, based on the mean of empirical data. Nice one. Any attempts? Any attempts? How are probabilities determined in a rectangular distribution? Based on observed frequencies, proportional to the number of events in the sample space, okay, unequal and dependent on each other, based on the number of empirical data. The answer is what? Can you tell me?
The answer is D, sir.
Is D. Interesting. Based on the mean of empirical data. Wow, seriously? Maybe this is the first time I'm seeing mean appearing in probability, right? Right? Maybe not the mean. Remember rectangular distribution. Each of the outcome has what? Equal probability. And if you want to compute the probability, what you do, you perform an experiment and then you count the number of favorable outcomes, which you will divide by the total number of what? Possible outcomes. So the right answer here, without wasting time, is what? Is A. Is based on observed what? Observed frequencies. Okay? All right. So we can proceed to the computational problems. Here we have 30 questions. Let us start with maybe attempting to solve 6 of them. If we still have time, we can solve more. So if you are solving 6 out of 30, that means we take multiples of 3, right? Or 5. 5 times 6, 30. So in that case, we are going to pick problem number 25. Are we good? Problem 25. It says, A deck of 52 cards is shuffled. Of course, a normal card, a deck of normal playing cards should contain 52 cards, right? What is probability of drawing an ace? Okay, you have a deck of cards, 52 cards. What is probability of drawing what? Ace. Probability of drawing ace will be number of aces you have in the deck divided by total number of what? Of cards. So number of aces, how many aces do you have in the deck of cards? You agree with me is what? Is 4 divided by 52. So we can make the division 1 over 13. So the probability is what? The answer is 1 over 13. Is the answer there? So the correct answer is option A. Is it okay, everybody?
Yes, sir. It's 1 over
Excellent.
30.
Perfect. So we can go to problem number 30. Okay. So problem 30 says,
Yes.
A coin is flipped 4 times. A coin is flipped how many times? 4 times. What is the probability of getting at least one tail? This is amazing. Probability of getting at least what? One tail. If a coin is flipped how many times? 4 times. Okay. At least one tail, it means you can get 1 tail, 2 tails, 3 tails, or what? 4 tails. This is one thinking about it. So that means you calculate the probability of getting 1 tail, exactly 1 tail. Then calculate probability of getting exactly 2 tails. And then calculate probability of getting exactly 3 tails. And then calculate probability of getting exactly 4 tails. And then you add them together. This is one way to do it. I hope you remember this type of probability. By the way, this type of probability is called what? Before we start the solution. When a coin is flipped 4 times. When a die is rolled several times, 10 times, 15 times. But you have to be careful with the die. It's different from a coin. Because a coin, it has how many options? Only 2, right? Either head or what? Or tail. So this type of probability is nothing but what? Binomial probability. Are we okay? Binomial probability. And then I want to believe you remember the formula. Probability of exactly x equals to k equals to n choose what? K. P to the power k. 1 minus p to the power n minus k. You remember this? You remember
Yes,
that?
Yes, sir.
Perfect. So this is probability of getting choosing one out of so many trials. So if you want to get probability of at least what? 1 tail, probability of at least 1 tail, at least 1 tail is going to be probability of exactly 1 tail plus probability of exactly 2 tails plus probability of exactly 3 tails plus probability of exactly 4 tails. This is one way to think about it. Because they say at least. Is it okay? Another way to think about this is to use the complement rule. Okay, so use what? The complement rule. I want to believe that I can convince you that probability of at least 1 tail, if we move around it, we can write it as probability of at least 1 tail. Okay, we can write it as 1 minus probability of no tail. Do you see this thinking? Complement. If at least 1 tail, then the complement is what? No tail. And by complementary rule, or by complement rule, The probability of at least one tail can be written as probability of in form of probability of no tail. So this can be written as 1 minus probability of what? No tail. This will be easier for us. I don't know if you think about this way. Probability of at least one tail is the same thing as 1 minus probability of no tail. Okay? So this work, which you have, if you use this first method, you will pass through how many calculations? 1, 2, 3, 4. But if you use the shorter approach, it will be easier for you to get to where you are going using your knowledge of what? Complement. So this, we can have probability of no tail, that is x equals to 0. Let me pick my pen. Okay, maybe I should not even clean it. Let me put it back. Probability of no tail, probability of no tail equals to probability of x equals to what? 0. Okay? And x equals to 0, remember, using our formula, using this formula, p x equals to 0 is the same thing as 4, because how many times 4? Combination 0, p, which is probability of tail. P, probability of tail. Okay, let me write this. Probability of tail, P into T equals to what? Half. I want to believe you agree with me. Probability of tail when you flip a coin is what? Half. So this is going to be half raised to power 0, 1 minus half, 1 minus half raised to power 4 minus 0. Is it okay? And 4 combination 0, I want to believe that you agree the answer is 4. 4 combination 0, 4 combination 0, 4 factorial over 0 factorial, then 4 minus 0 factorial. So this is 4 factorial over 4 factorial. It's actually what? 1 and not 4. Is it okay? This is what? 1. Then half raised to power 0. Any number raised to power 0 is what? 1. Then 1 minus half to the power 4, that is half raised to the power of what? 4. So the answer is 1 over 2 raised to power 4 is what? 16. Is it okay, everybody? So probability of no tail at all is what? 1 over 16. I want to stop here and then hear your voices. What do you see about this before we proceed? Probability of no tail is 1 over 16, correct? Clear to everybody?
Yes, sir.
Perfect. So if probability of no tail is what? 1 over 16, then probability of at least one tail, at least one tail, will be 1 minus probability of a no tail. And this is equals to 16 minus 1 over 16, which is equals to 15 over 16. So the right answer is 15 over 16, which is what? Option A. Is this okay, everybody?
Yes, sir.
Yes, sir. It's okay, sir.
Excellent. So we can proceed to the next problem, which is problem number 35. Problem 35 says, the probability of a defective bulb is 0.02. The probability of what? A defective bulb is 0.02. In a batch of 10 bulbs, in a batch of what? 10 bulbs, what is the probability of getting exactly 2 defective bulbs? Interesting. For every time you are seeing probability asking for exactly, your mind should be moving towards binomial. Number 2, whenever you are seeing present, absent, yes, no, defective, non-defective, then that is, you only have two options, remember, and that will lead you towards, again, binomial. So without further explanation, this particular probability question is binomial, because we have probability of getting, oops, which question am I reading? Maybe not that one. I was reading 34.
So you are reading,
It's supposed to be 35.
You are reading 34.
Okay, I've just explained that 34 for you. Perfect.
Yeah.
So when you are solving the problem, it will be easier for you. Let's go to our main question. 35. What is probability of getting two kings consecutively without replacements from a deck of 52 cards? Conditional probability, right? Probability of getting what? Two kings consecutively without replacement. Huh? Okay. So this is going to be probability of two kings. Remember kings, huh? We have how many kings in a deck of cards?
52.
In a deck of cards, kings. How many kings are there?
Should be 2.
13. We have 13.
Yes.
You see, all of you better buy a deck of cards. I'm sleeping with it. So
It's 3.
It's 3. Hey. Okay. So we have 52 cards. And then for each of the cards, the king, the queen, the jack, the house, and then the number cards, each of them, they are equally spaced. That means for each of them, you have 4 of them. But 4 times 13 will give you 52. So you have 4 kings. You have 4 queens. You have 4 jack. You have 4 as. You have 4 2. You have 4 3, 4 5 6 7 8 9. The number cards. Each of them you have 4 4. So you have 4 kings. So probability of obtaining 2 kings is going to be probability of obtaining the first one, which is 4 divided by 52. But they say without replacement. By the time you are drawing the second one, instead of 4, now you have 3. Then divided by, instead of 52, you have what? 51. So probability of obtaining 2 kings without replacement is going to be the product of the probability of the 2 events. Okay, but because it is without replacement, by the time you want to draw the second king, you've already drawn 1, conditional probability. So we are left with what? 3 instead of 4. And then the number of cards will reduce from 52 to 51. So this is how you move along with this. And then you can simplify this. 4 here 1, 4 here 13. So you have 3 divided by 13 times 51. But 3 can also go in 51 too. Is it? 3 here 1. How many 3 in 5? 1. Remainder 2. Then how many 3 in 21? That gives what? 7. So you have 1 over 13 times 17. Is this correct? And what is 13 times 17? 1 over 221. Is this correct? Excellent. So the probability of obtaining 2 kings without replacement in a deck of cards is what? 1 over 221. So the right option there is option B. Is it okay, everybody?
Yes, sir.
Good. Is it okay? Perfect. We go to the next problem, and that is problem 40. Problem what? 40. It says, the mean number of successes. Hey, I didn't teach you this aspect. The mean number of successes in a binomial distribution is 8. The mean is what? Is 8. With n equals to 20, n the number of observations, the repeated number of experiments. What is the probability of success? What is P? Okay. Binomial distribution has mean, and at the same time, it has standard deviation. Take note of this. Binomial distribution, it has mean, and then it has what? Standard deviation. The mean of a binomial distribution, mu, is MP. The product of the number of times you repeated the experiment and what? The probability of success. And the standard deviation of a binomial distribution is the square root of MP into bracket 1 minus P. Interesting. The standard deviation, we didn't cover this topic in class. These aspects of this, we didn't cover it in class. Okay, so the mean of binomial distribution is what? MP. N is the number of repetition in your experiment, and P is the probability of success. While the standard deviation is the square root of what? MP, which is again the mean, and then multiplied by the probability of what? Failure, 1 minus P. Remember, if P is probability of success, then 1 minus P is probability of what? Failure, binomial. And by the way, you can see from here that you can get variance, which is the square of what? Standard deviation as a MP into bracket 1 minus P. Okay, these are very important. This one is standard deviation, and this one is what? Variance. Okay, so this question is about the mean. You are given the mean to be 8. You are given N to be 20. You are not looking for what? For P. Using your formula, mu is what? MP. Your mu is 8 multiplied by what? P. That means P equals to 8 over 20, which is what? 4 over 5, right? Okay. 4 over 10. And then 2 over, let me take my cleaner. 4 over 10, right? And then 2 over 5. So the probability of success is 2 over 5, which you can take the decimal as what? 0.4. Is this okay, everybody? So the right option there is option B, right? Option B. Please, is this clear to everybody? Please take note of this formula. This was not given in class. Yeah, this was not given in class. The mean of the binomial distribution is MP. N is the number of repetition in your experiment, and P is probability of success. Why the standard deviation is the square root of MP, which is again the mean, then multiplied by 1 minus P, which is the probability of failure. And then the variance, you can go on. So in this case, we are given the mean, we are given N, and we are looking for P. We just divide 8 over 20, then we say 2 here, 4, then 2 here, 10. We reduce it again, 2 in 4, 2, 2 in 10, 5, and then we convert to decimal to get 0.4. Okay. So we can go to the next problem. Yes?
Excuse me, doctor.
Yes, go ahead, please.
Is it mandatory that you convert it to decimal point, or you leave it at 2 over 5?
You can leave it as 2 over 5, but when you look at the options given, you find that all the options are in decimals, right? So that means you have to convert to decimals. Okay? Look at the options. All of them are in decimal. So that, you know, initially I also left it as 2 over 5, but when I look at the options, I find that the options are in what? In decimal. So I have to convert it to decimal. Perfect. So question number 45. Okay. It says, if a 6-sided die is rolled 3 times, what is probability of rolling a 6 at least once? What's probability of rolling what? A 6 at least what? At least once. It's like I will leave this one for you to do, because it's similar to what we just did before. If it is at least once, then that will be 1 minus probability of no 6. Huh? 1 minus probability of what? No 6. Are we okay? Probability of obtaining a 6 is what? At least 1 6. And you roll the die many times? 3 times. So probability of obtaining at least 1/6, let me write it down. Probability of obtaining at least 1/6 is going to be 1 minus probability of no 6. Okay? So this is pretty easy, yes? What is probability of obtaining 6? 1 over what? 6, right? In the fear of that. Then if this is probability of obtaining 6, probability of no 6, no what? No 6 is going to be 1 minus probability of 6, and this is going to be what? 5 over 6, right? No 6. But remember, the die was rolled how many times? 3 times. That is binomial, using your binomial now. So probability of no 6 3 times. No 6 3 times. Okay, it's going to be 5 over 6 raised to the power of what? 3. 5 over 6 times 5 over 6 times 5 over 6. Okay? So what do you get? 5 over 6 times 5 over 6 times 5 over 6. What is 5 times 5 times 5? 125, right? Please, we need the calculator, people. What is 6 times 6 times 6 times 6? What is 6 cube? That's 216. Is this correct? So this probability of no 6 when a die is rolled 3 times. So a probability of at least 1/6 will be at least 1/6 will be 1 minus probability of no 6. So, and this will be 216 minus 125 divided by 216. What do you get? I want you to tell me the answer to this one. It is what? What is 216 minus 125?
91 all over 216.
Thank you. 91 over what? 216. So this is your answer. And the right option there is option what? Option D.
Okay.
Interesting, yes? Any question on this? So you need to know how to manipulate this tool, as in complement rule is very important. Complement rule. Amazing. All right. Let's go to the last question on the list. That is question number 50. Question 50 says, a bag contains 4 red, 3 blue, and 2 green balls. 4 red, 3 blue, and then 2 green balls. If 3 balls are drawn at random, if 3 balls are drawn at what? Random. What is probability that they are all red? Probability of red, red, red. This is a very important probability question. And one thing you must observe in this question is that you were not told whether it is without replacement or with replacement. In any question that you are given, and there was no mention of without or with replacement, your basic assumption is going to be the draw was done without replacement. Because when you pick a ball at random, naturally you don't have to replace. So if it is with replacement, the question will tell you. But if it is without replacement, whether the question tells you or didn't tell you, you should know that the picking of the balls or the picking of the whatever thing they are picking is what? Without replacement. So we are picking 3 red balls consecutively without replacement. What is now the probability? Probability of picking the first one is going to be, how many reds do we have? 4, huh? Divided by total number of balls. 4 plus 3 plus 2, which is what? 9. Multiplied by, when we pick the second red, now we have 3 red balls left, and then we have total number of balls to now be 8. By the time we pick the third one, we have 2 red balls left, divided by what? 7. Is it okay, everybody? So this is the probability of picking the red ball 3 times. So we can reduce this. 4 here 1, 4 here 2, 2 here 1, 2 here 1, 3 here 1, 3 here 3. At the numerator here, we have 1, 1, 1. 1 times 1 times 1 is 1, divided by. At the denominator, we have 3 times 1 times 7. 3 times 1 is 3. Then 3 times 7 is what? Is 21. So probability of picking all red is what? Is 1 over 21. And the right option is option D. Huh? Is it okay, everybody?
Yes, sir.
Yes.
Very
I have to
okay.
believe we are very okay. Perfect. I like that word. Very okay. Excellent. So I hope it will be very okay when you're having your test too, yes?
Yes, that's our
Perfect.
prayer.
Yes, it will be very okay. So we still have 6 minutes. Let's see if we can solve 2 more problems. Let me just pick problems at random. Of course, the one that you have not picked before. Let us see problem number half down the line. Maybe that's 34, right? Or let me pick 33. 33 is easier. Yeah. 33 is very easy. Let me just explain it. If the probability of event A is 0.3, event B is 0.4, and A and B are what? Independent. What is probability of A and B? Remember? Product rule. Probability of A intersection B, Christmas cap. Probability of A multiplied by probability of what? Of B. By the way, we are getting closer to Christmas now. Yes? So because the 2 events are what? Independent. So this is as simple as probability of A is given to be what? 0.3 multiplied by probability of B, which is given to be 0.4. And this is what? 0.012, right? Or something like that. Or 12. 0.12. Huh? That is the answer.
Sir, please solve 36.
Problem 36.
Yes.
Thank you. Nice one. It says, in a group of 10 students, 4 are selected for a project. What is the probability of selecting all 4 from a subgroup of 6 students? Madam, your eyes are very sharp, bro. This question 36 is tough. In a group of what? In a group of 10 students, 4 are selected for a project. What is the probability of selecting all 4 from a subgroup of 6? Probability of selecting what? All 4 from a subgroup of what? 6. Do you remember permutation? You are choosing 4 from 6. Okay? And then you are choosing 4 from 10. The very important thing is for you to know your sample space. What is your sample space? Your sample space is coming from the first line. In a group of 10 students, 4 are selected for a project. That is your sample space. Out of 10, we are selecting 4 of them at random, which is what? 10 permutation. Be careful there. 10 permutation 4. That is your sample space. But event space is saying, What's probability of selecting this 4 from a subgroup of what? 6. Probability of selecting 4 from what? A subgroup of 6. That is the event space. Remember, event space is a subset, is a subgroup of sample space. So your event space is going to be selecting 4 from what? From 6. So your probability that we are looking for, of the whole event will now be the favorable outcome over total number of what? Sample space. And what is 6 permutation 4? 6 permutation 4 is what? 6 factorial divided by what? 4 factorial. Divided by, what is 10 permutation 4? 10 factorial divided by what? 6. No, 4 again. Where's my 10? Is it correct? Is this correct? What is n permutation k? Before we proceed, remind me. What is n permutation k? Oops. What is n permutation k? N factorial divided by, is it n minus k or k factorial? Somebody who took note.
N permutation.
Are you checking your notes? Is n factorial minus n minus k what?
It should be all
Factorial.
about k permutation, sir.
N minus k factorial, not k factorial. So this, what we have here, supposed to be 6 factorial divided by 6 minus 4, which is what? 2 factorial. And this one is 10 factorial, 10 permutation 4 is 10 factorial divided by 10 minus 4 factorial, which is what? 6 factorial. So you can do this as a 6 factorial divided by 2 factorial. Your division, you can change it to multiplication. 6 factorial over what? 10 factorial. So you can now simplify this. You can do what?
6 times 5 times 4.
So you can now simplify this. What is 6 factorial divided by 2 factorial? Tell us. 6 times 5 times 4 times 3. 10 times 2 factorial over 2 factorial. So that this can go. Then multiply by 6 factorial over 4 factorial. That's what?
6 times 5 times.
6 factorial divided by 10 times 9 times 8 times 7 times 6 factorial. Madam, your eyes are very sharp for picking this question. So 6 factorial, we go with 6 factorial. 2 factorial, we go with what? 2 factorial. So your answer will be 6 times 5 times 4 times 3. This is 1 now, divided by 10 times 9 times 8 times 7. So you can always reduce this and get your answer. 5 in 5, 1. 5 in 10, 2. 3 in 3, 1. 3 in 9, 3. 4 in 4, 1. 4 in 8, that is what? 2. 2 in 2, 1. 2 in 6, that is 3. And I think we are done. Okay? And I think we are done. 3 times 1 times 1 times 1. Maybe something is mistaken somewhere. But this is how you go. Then 2 times 3 times 7. 2 times 3, that is 6. Then 6 times 7, that will give you 42. Okay? We can still divide. Yes, you can still divide. 3 here, 1 over 3 in 4, 1, remainder 1, then 3 in 12, that's what? 4. So the answer, according to our calculation, is what? 1 over 14. Oh, the option is there, option D. Interesting. So 1 over 14 is the answer. Yes, interesting. Madam, thank you for engaging us on this interesting question.
You're welcome, sir.
Yes, we will be able to have the video, I think. So I'm recording it. Hopefully, we are going to get it. So for those who couldn't catch up now, you can review the video. All right, the time is fast spent. You have to stop the class now and continue next week. Thank you so much.
Thank you, sir.
Your attention.
Thank you, sir.
Yes. See you again.
Thank you.
Next week.
All right, sir.
Have a good
Yeah.